A bullet from a sniper rifle travels faster than the speed of sound. 1. By the time a target hears anything, it's already over. But putting that bullet exactly where it needs to go, from a mile away, or 2 miles, or more, that's not just marksmanship. It's physics. It's physiology. It's a discipline so exacting that the shooter must control their own heartbeat to do it. This is the science of the sniper. And it begins, not with a gun, but with a bird. The word sniper comes from a bird. In 18th century British India, soldiers hunted the snipe, a small, fast, erratic creature nearly impossible to hit. If you could shoot one, you'd earn the name. And the name, over centuries, migrated to the battlefield. For most of military history, skilled marksmen existed. Formal snipers did not. That changed in the mud of the Western Front. World War I turned warfare into a waiting game. Armies faced each other across narrow strips of open ground. To raise your head above a trench wall was, often, to die. Both sides urgently needed men who could kill at distance, from concealment, without being seen. The 2-person sniper team was born out of necessity, one to shoot, one to spot, a structure still used by every military on Earth today. 3 figures define what this science looks like in human form. Finland. Winter. 1939, a farmer named Simo Häyhä, 5 feet 3 inches tall, put on white camouflage, walked into the snow, and began. He refused to use a telescopic sight, believing the glass would catch the light and betray him. He trained his naked eye until it was precise enough. He packed snow in his mouth so his breath wouldn't cloud in the freezing air. Over 100 days, he accumulated over 500 confirmed kills. He survived a direct hit from an explosive bullet to the face, and lived to 96. The Red Army called him the White Death. At Stalingrad in 1942, Soviet sniper Vasily Zaytsev turned a destroyed city into a hunting ground. He hid in rubble, in water pipes, in the wreckage of buildings, anywhere that gave him a concealed position. He killed over 225 German soldiers, trained dozens more, and understood something essential: patience, in this work, was the sharpest weapon of all. In Vietnam, U.S. Marine Carlos Hathcock crawled for 3 days and nights, more than 1,500 yards through enemy-held jungle, moving inches at a time, to reach his position, fire a single shot, and disappear. He was nearly stepped on. He was bitten by a snake. He kept going. He said, "The deadliest thing on the battlefield is one well-aimed shot." The moment a bullet leaves the barrel, its fighting nature on every front. Gravity pulls it toward the ground. Wind pushes it sideways. Drag slows it down. Heat reduces air density and changes how far the bullet drops. Higher altitude means thinner air, the bullet carries further. These are the variables most people think about. But at extreme range, the physics becomes something else entirely. A spinning bullet drifts. The rifling in the barrel imparts rotation, and over distance, that rotation pushes the bullet sideways, in a phenomenon called spin drift. Then there is the Coriolis effect. The Earth rotates at 460 meters per second at the equator. A bullet in flight is no longer attached to that rotation. While it travels, the ground beneath keeps moving. At 1,000 yards, this deflects the bullet approximately 3 inches sideways. At 2 miles, the error is measured in feet. Research from the U.S. Army Marksmanship Unit found that a 1% error in wind estimation, combined with failing to account for the Coriolis effect, produces a total deviation of 12 to 15% at 1,500 yards. In ballistics, errors don't add. They multiply. A small mistake at the calculation stage becomes a catastrophic miss downrange. Modern snipers carry portable weather stations that measure wind speed, humidity, temperature, and barometric pressure simultaneously. They feed that data into ballistic calculator software that generates a firing solution: how high to aim, how far to compensate for the wind, what the bullet's spin will do over the full distance. They are doing physics. In the field. Under pressure. In real time. Physics can be calculated. The human body has to be controlled. Every heartbeat sends a pulse of blood through the body, and when that pulse reaches the trigger finger, the fingertip swells. Fractionally. Invisibly. But at 1,500 meters, a deviation of fractions of a millimeter at the rifle translates to meters at the target. Expert snipers fire between heartbeats, in the brief window called the cardiopulmonary pause, when the body is, for a fraction of a second, completely still. To create that window, they control their breathing. 18 breaths per minute becomes 6, slow, diaphragmatic, deliberate. As breathing slows, heart rate follows. The pause between beats lengthens. The window opens. Then the trigger. A 2023 peer-reviewed study from the Norwegian Armed Forces found that incorporating mental skills training, mindfulness, stress inoculation, cognitive control, measurably improved performance on a real advanced sniper course. The mind and the shot are not separate. The mind is part of the shot. Snipers are trained to achieve a state of controlled calm in conditions of genuine danger, incoming fire, extreme heat, exhaustion, and the psychological weight of the decision they're about to make. Through all of it, they slow their breathing, lower their heart rate, and find the stillness between beats. No other field of human performance requires this exact combination of applied physics, physiology, and psychology in a single moment. On a November morning in 2023, a 58-year-old former Ukrainian businessman named Vyacheslav Kowalski lay in the snow and aimed at a Russian officer 3,800 meters away, the length of over 42 football fields. He wasn't a professional soldier. He had enlisted after Russia's full-scale invasion. His first shot missed. He adjusted for wind. His second shot did not miss. It was the longest confirmed sniper kill in recorded military history, at the time. Less than 2 years later, an unnamed Ukrainian sniper from the elite PRYVYD unit broke that record, 4,000 meters, 2 soldiers, 1 round through a window. But this shot carried a new distinction. For the first time in the history of long-range kills, it was assisted by artificial intelligence. A reconnaissance drone tracked the targets. AI systems calculated variables in the firing solution and confirmed the hit. What once required years of training to estimate by feel and calculation is now being processed by machine, in the field, in seconds. The sniper has always stood at the edge of what human skill and science can achieve together. The physics is extraordinary. The training is brutal. The technology is advancing faster than ever. In that silence, one breath, held. One finger, waiting. And then the science does the rest.